Hello, you're listening to Inside iOS Dev, a show about real-world iOS development, here with your host, Andrew Rohn.
And Alex Bush.
And today, we are doing the much-anticipated second installment to the Clean Code book by Robert Martin, or also Uncle Bob, also known as Uncle Bob, doing the second installment of kind of this overview of it, the Cliff Notes. We, of course, recommend you purchase his fine book.
And not only purchase, but read it as well.
That's the key.
Yeah.
But he'll probably be happy if you just purchase it.
You know, it feels good. You have these piles on.
I'm sure he wants you to read it too. But yeah, so we will go over that today. Last time we went over the first 5 chapters. You can listen to that episode in the backlog. I forget the exact title. It's like Clean Code Overview Part 1, something like that.
Writing Clean Code Part 1.
Woo! All right, here we go with the second installment. This is our highest, the last one on Clean Code Part 1 was our highest listened to episode, most downloads. I'm very proud of actually our listenership. They know that the good stuff, we got right? A smart group. They know what the good stuff is. Okay, we're doing this. We're starting off.
Right? Yep.
Okay, cool. Chapter 6, Objects and Data Structures. Okay, I have some notes here. What does he say here in Chapter 6, Objects and Data Structures? And this one, he talks about kind of, I'll just give an overview really quick. He just talks about the difference between objects and data structures, kind of when you would choose them and kind of defines them. So he says, basically, with objects, you're hiding their data behind abstractions, and you're exposing functions, methods that operate on that data.
Which is behavior, essentially.
Yeah, kind of classic OOP. I think most people know that. On the other hand, data structures expose their data and have no meaningful functions.
Right, and I guess in the context of iOS, those would be class objects from classes or off classes, right?
An instance of a class.
Exactly. And the others could be literally structs in Swift, or
data structure would be like a struct.
Yep. Or like dictionaries, arrays, linked lists, and so on.
Yeah. One interesting point that he made, he talks about data transfer objects being the quintessential form of a data structure class with public variables and no functions. And then he gives the example of active records as a special form of these DTOs. Basically, they're just like these useful things for parsing data, raw data into objects. And then if you want to add business rules, you create a new object that hides the data and contains, hides the data and contains these methods for operating on it. And then you made a good point earlier about
like in the
manage objects and kind of the context of iOS world.
Right, yeah. So instead of active record is it's a Rails backend data structure for working with databases. In the context of iOS, it would be an managed object subclass, right? And working with core data. So same thing, right? Like a lot of code bases I saw, they would use core data and have an managed object subclasses to like represent their users or posts or whatever other models and entities they have in the code, but then they'll kind of retrieve that from the database and get it back from core data in the form of those subclass objects, but then they'll take that and like use it in UI, right? And that therefore couple it very tightly with the specific database implementation, core data, which kind of what Robert advocates is not a good idea, and instead an managed object context, an managed object subclass is
like this DTO.
Is a DTO, data transfer object there, and you should use it only for, well, I guess purposes of transferring data, but do not couple yourself to it.
Yeah, that was a cool explanation that you gave, and to me, my intuition was like I didn't want to be tracing. My intuition is I never wanted to be passing around these NS managed objects, because then I'm like having to pass around this thing that is a NS managed object, and I have all that behavior sticking around. I just don't want all that. If I have a person class, I want to make a clean class. Or if I have a person and let's say there's a manage object person, subclass, I don't want to be passing that around because then it has that NSMagic object behavior. It is an NSManage object. So I want to create a new class that like here where he says you just hide the data and you expose these functions, and it's just subclass of an NS object or
whatever else, but it's your stuff rather than some framework stuff.
Yep. Because then I get exactly just the stuff that I need, and I'm not committing myself to this inheritance hierarchy and just bringing all this crap along for the ride. I don't need any of that. Yeah, so he says objects, it's kind of from the notes here, objects expose behavior and hide data. This makes it easy to add new kinds of objects without changing existing behaviors. It also makes it hard to add new behaviors to existing objects. Data structures expose data and have no significant behavior. This makes it easy to add new behaviors to existing data structures, but makes it hard to add new data structures to existing functions. And then he says, in any system, we will sometimes want the flexibility to add new data types and so prefer objects and object-oriented programming. Other times, we will want the flexibility to add new behaviors and so prefer data structures and procedures. Chapter 7, Error Handling. In here, Uncle Bob talks about error handling, how we should separate it out from our kind of, what does he call it? Business logic, I guess?
Yeah, the domain happy path, you called it?
Yeah, I guess error handling is like its own responsibility and it should be separated out from your normal logic.
Right, yeah, it should not abstract and make your normal quote-unquote logic unclear. I guess
and he also gives a lot of examples. This is mostly about like the try-catch block, I feel like.
Right.
In Objective-C, that's not really a thing.
Yeah, we have these pointers to errors.
Yeah. You have like this in-out. I guess like it would be in Swift where you have the in-out parameter, which is the error, which is just passed by reference, and then from that you check if there's an error. But in Swift there is...
You do that.
So this would be more... I feel like this chapter would be more appropriate for Swift and not as much for Objective-C.
Right.
Although the message of handling your error, kind of it being its own responsibility, I feel like that message can still...
Yeah, regardless, I guess, try-catch or not, or a pointer to an error is kind of a implementation detail of how you handle errors. The main point is you gotta handle them.
Yeah. So yeah, he says error handling is just one of those things we all have to do when we program. And he says it's important to do error handling, but if it obscures logic, then it's wrong. Meaning if it just makes the readability of your code worse, then you didn't do it right. One thing I thought was interesting, he said we should avoid returning or passing null from to functions to avoid errors. Consider throwing an exception or returning a special case object instead, which I thought was interesting because I feel like in Objective-C, we pass nil into functions a lot. And that's just like a kind of a pattern in a way.
Right. And this is what I think in our previous episode, I kind of called it a null pattern,
object pattern.
Null object pattern for free. Basically, the fact that you can send messages to nil and nothing will happen, so you kind of use it. And in every scenario in your code, it kind of means something. There's an implicit meaning to it. Instead of explicitly, if you define with a null object pattern, you define like, there's this, roughly speaking, the simplest example of that would be a user, right? You have a logged in user and you have a user object, but you might have a null user, aka guest, right? And they both implement the same interface. So instead of returning, asking your manager or some user manager, give me the current user, instead of returning null when your user is not logged in, you would return a guest user object. And you can work with that and you don't break anything. And you don't if-else anywhere. You send it the same messages. Like first name, last name. Guest object is going to return, I'm a guest, or something like that.
Mm-hmm.
And another, like, that would be that, right? And another thing to add to what he was saying with kind of nulls in general. Swift helps with that a lot. I like it. I like it a lot, where you define something being nullable or not with optionals. That's really explicit and nice. Helps with, I guess, being explicit and clear.
Right. Last kind of bullet point I wrote here. We can write clean code if we see error handling as a separate concern, something that is independent of our main logic. Separate the two out. Yeah. Makes sense. Okay. Chapter 8, boundaries. We can't control all the code in our system. We rely on third-party frameworks or use open source. We need to cleanly integrate with this foreign code. The natural tension is that an interface provider strives for broad applicability, while an interface consumer, that's us, the developers, wants something that's focused on their particular needs. Makes sense.
So abstraction versus concretion, I guess.
Can we give an example so we can...
Well, any framework you use, big or small, right? The framework developers, they want to make it broad for everyone, so that it's marketing, right? So everyone's using their thing. And we developers, we build that specific concrete app, and we want to make it...
We have our own specific needs.
Yeah. Okay. AF networking,
right?
Or like Aloma Fire, would be that. They give you this, broad abstracts, not specific at all interface for doing HTTP requests on the web. But when we develop, we typically we have our own like API client object that wraps around that AF networking object to give us specific requests to our backend API rather than, some abstract thing.
Right. Okay. And that kind of leads to the next point. Hide third-party code behind a wrapper class or adapter. Don't couple yourself to it.
Right. Yep. Whatever that is.
He gives an example here. He talks about the Java map, which is what?
Well, we have map in Swift.
Okay, yeah, but it's the hash map. Most people, I guess,
Dictionary.
Dictionary.
Yeah.
Most people, dictionary map. They're essentially the same thing. Associative array. But yeah, let's just say a dictionary. So a dictionary has a very broad interface, and exposes methods that you might not want others to use. Like, what is it? Remove all.
Right. Yeah.
So let's say you have a dictionary holding a persons or something like that. I don't know. And you don't want anyone to have access to that remove all method. So what you do is you create like a person dictionary that wraps around the dictionary. And then now you don't expose the remove all method on that person dictionary. And the other nice thing is, this goes back to the point about framework code not being specific to your needs and you wanting to tailor it. Well, now on the dictionary, it will just return back. What would it be? The
like
return time's like an ID or just a
object, right?
raw pointer. Just pointer to any object or something. Well, now what you could do is on the return type, you have it return a person.
Yeah, you cast it, roughly speaking.
Yep.
But then no one knows about the casting.
Yeah.
They shouldn't know.
So anyone using this person dictionary now does not have access to removing all, which would be dangerous for whatever reason in your code. And now they don't have to be doing ugly casting everywhere because they return a person object from this person dictionary. So that's a way of how you wrap framework code, and with your own kind of custom class, and then have specific behavior.
And also, kind of to add to that casting you might think is innocent right now, but most of the time it ends up being an if-else everywhere across your app, because every other place that uses your dictionary doesn't know what the hell is inside, or rather they need to assume, but just in case, because of the crashes, they would check. So here you go, you got an if-else, and they're just going to breed.
Yep. Okay, next chapter, chapter 9, unit tests. Our favorite one, right, guys?
Yay!
Wink, wink. Nudge, nudge. Test code is just as important as production code. These are the words of Bob Martin now. With test, you feel safe to make changes to the code. This prevents code rot. Yeah, like if you have test and you have a sense of safety, I don't think unit tests will ever give you 100% safety.
Nothing will, but
Nothing will, right? So, but it's like degrees of probability and things like that, where you can say like, okay, fine, I'm going to go in here and make changes, and you will feel more comfortable making changes, which will prevent code rot. Because now, without tests, you'd be like, I'm afraid to go in there. Like
what if I break?
What if I break it? I don't want to mess with it. So with tests, you feel more confident to change code, which prevents code rot, which is great. Unit tests keep code flexible, maintainable, reusable. So this is an interesting point. Having dirty test is at least as bad as having no test, meaning having dirty test is potentially worse than having. Having dirty test is potentially worse than having no test at all. Right?
I guess false positives and all.
False sense of security, maybe that's what it is. So I thought that was interesting. So your tests need to be clean.
I mean, it's your code anyway, right? And you kind of like we talked about it a little. You could potentially fall into the same trap of like coupling yourself too much in your test code to like particular concrete implementations of frameworks or whatnot that you use, and kind of same problem as with production code, right? You change some little thing somewhere there with your core data and an managed object subclass, right? And boom, you got 1,000 tests failing because of that little change. No bueno.
Right, and so that segues kind of into the next point. He says, how do you write clean tests? The same as production code. Readability, clarity, simplicity, etc., so on. He advocates using TDD, test-driven development.
Yay!
Yeah, and so the 3 laws of TDD. You mustn't write code until you have written a failing unit test. That's the first one. Second, you mustn't write more of a unit test than is sufficient to fail. And the third is you mustn't write more production code than is sufficient to pass the currently failing test.
Yep.
I've actually never really done TDD. You've done TDD.
I've done TDD. I want to say a lot. Just, I guess, not with iOS a lot.
It's not really a thing in the iOS world. Is it a thing in like general?
It's actually becoming a thing. At least ThoughtWorks does it a lot. So, and I've been doing it lately. I can say it's there finally.
Okay, and then I have a last bullet point here. Clean tests follow the first acronym. F is fast, I is independent, R is repeatable, S is self-validating, and T is timely.
I like that one.
Yeah.
All right, guys, that's it for today. You should go listen to the first episode. It's the full title is Writing Clean Code Part 1, an overview of Robert Martin's Clean Code. And we're gonna definitely have another episode, most likely 2 actually, to finish with the rest of the chapters. And follow us on Twitter at Inside iOS Dev, and email us at hello@insideiosdev.com.
Yeah, and check out Alex's book, iOS Interview Guide.
Yeah, it's good.
Where do I find it?
It's iosinterviewguide.com.
Man, that's what helped me get a job at Reddit. It's a big help. Guys should check it out.
Yeah, and again, email us if you have questions.
All right, hope you enjoyed. See you guys soon. Bye.